All right, hello, and this is a Chuck talk about unit conversions, and we're going to talk about unit conversions that include, this is references, kilo, and then the base unit, and milli, micro, and nano. And the base unit could be meters, grams, liters. The conversions are the same, irrespective of the base unit, because we're focusing on these prefixes. That means that these problems will be solved the same way also for the unit molarity and also the unit moles per liter. And we'll talk about those, and later in the video I'll introduce those and describe those units. But to start out with, we focus on conversion of any of these as equivalent. And it goes like this. A kilo is 1,000. Milli is 1,000th. Micro is a millionth, or 10 to the minus 6th. And a nano is a billionth, or 10 to the minus 9th. So big unit and small, smaller, smallest. And to start out with, just to talk about this, these represent sort of placeholder positions in numbers. So if we write numbers out like this, or that's the decimal point, each of these is responsible for 3 place positions. So for example, you could have 1 gram, and you could have 990 grams, but when you get to 1,000 grams, you've got 1 kilo. So kilo starts here and goes up. So you could have 999 kilos. Same way down here. That's 1 millimeter, 1 micrometer, 1 nanometer. If we have 999 nanometers and we add just 1 more nanometer, we get to 1 micrometer, like that. And so it's good to keep track of this, because sometimes unit conversions can be double checked with this, and it's nice to have a double check when you're working with unfamiliar units. And so, for example, one of the questions might be how many micrometers are there in 10 millimeters? And if you just go to this and write down 10 millimeters, that would be like this. And how many micrometers are there? And the answer is there are 10,000 micrometers. See that? And that's all we're doing here in these conversion problems, is we're converting from one unit to another, and we're really just sliding along this scale. How many millimeters in a kilometer? The answer is, well, there's a kilometer, and there is the millimeter, so there are 1,000,000 kilometers in 1 millimeter, like that. And so it's nice to have that as a double check. Now I'm going to represent this conversion in the form of a math equation. And students have often learned this before in a variety of different ways. There are going to be 4 numbers represented, and in some classes you would have learned those 4 numbers like in an equation that looks like that. Another time you might have learned them in a math class where the equation starts out looking like that. And for us, we're going to start out with the equation. They're equal equations. It's just for how the numbers have been solved. We're going to start out with an equation and use an equation that looks like that. So you might have learned to cross multiply and divide or other methods. We're going to talk about this idea right here. And in this simple equation, we use the A is what you have, and D is what you want. And then B and C are a fraction or a ratio we create. to make the conversion. And in making the conversion, we're going to multiply a by a number equal to 1, because a number times 1 times a equals a. So we can add this, create this, and as long as we make a number 1 here, that will be a fair multiplication problem to solve. And our equation is going to be 1, and it's going to be same as 1 over 1, a fraction, 1 over 1. And so b over c has to be equivalent, like that. And what we're going to do is we'll put different units on the top and bottom of this fraction, and then different numbers in to represent the relationship where b equals c. So in 1 millimeter, there are 1,000 micrometers, for example. And this relationship between micrometers and millimeters is something that we're going to learn. And because that's where we have to put energy in, is we have to put energy into creating this fraction so that it's equivalent, okay? And so these are what the questions look like. How many liters in 12 milliliters, like that. So what do we have? The first part is 12 milliliters of this. We're going to multiply it by a fraction that equals how many liters, like that. And so the units we're working with are milliliters and liters, and they're going to go into this fraction. So we put those in first. We're going to put milliliters on the bottom, because when we solve this, we'll multiply milliliters over milliliters, and those will cancel, and we'll get rid of that unit. Then on the top, we're going to put liters, because that's what we want to get to. So now we have this fraction of milliliters over liters. We can usually go to a conversion table to find the relationship. The conversion table often represents the liters, or meters, or grams, or moles per liter, any unit. And then it will say, well, for a milliliter, like that, for the milli prefix, it is 1/1000th, or 10 to the minus third, because a milliliter is a really small fraction of a liter. So this is a really small number, showing that that a milliliter is just a small part of a liter. Working with small numbers is harder to think about, and so since we can choose what numbers to put into this fraction, I start out and I say for the big unit, whatever it is, the bigger unit, I'll just say, what if I had one of the big unit? If I had one of the big unit, I'd have lots of the small unit, because there are lots and lots of small units. How many are there? There are 1,000. There are 1,000 milliliters in 1 liter. And I've created this fraction b over c, where the b over c is equal. They're equivalent, because in 1 liter there are 1,000 milliliters. And that's our goal. And we can just multiply through this math. So we get 12 times 1 divided by 1,000. So we get 0.012 liters in 1 milliliter, like that. We can do this, go back to this number like this. And we'd say, oh, well, just to double check this, if we had 12 milliliters, how many liters would we have? We would have 0.012 liters, like that. And then another thing to say about this fraction is that in this relationship, these numbers are directly proportional to this, and this one is inversely proportional. And it's another way to think about what's going on here. As either of these numbers increased, this number would increase. As this number increases, this number would decrease. Here's another kind of problem to solve, and it could be how many, milligrams per milliliter are there in, say, 25 grams per liter, like that. Okay, so now we have to do 2 conversions, and the easiest way to do that is just to do them in 2 separate equations, just like we set up that equation, but we're going to do it twice. First, we'll change the grams to milligrams, and then we'll change the liters to milliliters. So if we write up this equation, we're going to start out with what we have, and we've got 25 grams per liter. And we put the liter in, but we're not going to fiddle with it. Then our fraction, and then how many milligrams. And for now, we have to leave this as liter because we're going to mess with it. And to get rid of grams and change to milligrams, we put grams on the bottom. So those will cancel when we do our math. And then we put milligrams on the top. When we multiply through, we'll get milligrams per liter. And now we got to put in numbers. Again, the big unit is grams. So what if we had 1 gram? How many milligrams in a gram? And we go to a unit conversion table, but it's pretty easy to memorize what these relationships are. It's 1,000 milligrams per gram. So when we multiply that through, we're going to have a final answer for this first step of 25,000 milligrams per liter. So put that down here. That's what we have now. And then we're going to multiply it through to get to our final how many milligrams per milliliter. So now we're going to fiddle with the liter. And in this case, the liter is on the bottom. So to get rid of it, we need to put liter on the top in their fraction. So that's a little bit different, just to notice that, but pretty clear why we do that. And we'll put milliliter, because that's what we want down here, on the bottom. So then big unit, liter, how many liters? 1. How many milliliters? 1,000, like that. We multiply it through, and we get a final answer of 25 million milligrams per milliliter if we have 25 grams per liter. Just trying to checking and thinking about that answer. It's wrong because it should be a division. So instead of 25 million, it should be 25 milligrams per mil as our final answer. So let me just rewrite that. 25 milligrams per mil. Okay? So there can be conversions like that. Then here's the next kind of conversion, and it goes like this. How many, say, micrograms in 22 milligrams? And this is a challenging one too, because the unit conversion tables don't have that direct conversion. The unit conversion table will go from milligrams to grams and micrograms to grams, but not from milligrams to micrograms. And so to solve this kind of problem, we can do that most easily by setting up 2. And what we're going to do is we'll first go from milligrams to grams, and then we'll go from grams to micrograms. So in this first one, we've got 22 milligrams, and we're just going to make it to grams because our conversion table has grams to milligrams, and we can do that by putting milligrams down here and grams up here. 1 gram is 1,000 milligrams, and so for this one we've got 22,000 grams in 22 milligrams. And no, that's wrong. Sorry. Good check on math. We have 0.022 grams. And you know how I checked that? I looked at this in my head. So if we have this and we write down 22 milligrams, right? It's going to be a small number. So that's one thing we can get to is if you got 22 milligrams, it's going to be a small number. How small is it? It's 0.022 grams, like that. So that's a double check, and like I said, I did it in my head just to double check because I made a foolish math mistake. And so now we do the second step where we're going to go from 0.022 grams to micrograms. And that'll be our final answer in micrograms. And in this case, we want to get rid of grams, so now we put grams on the bottom, so they'll cancel. We do our math, and we put micrograms on the top. In the table, it says if you have 1 big unit of grams, there are 1,000,000 micrograms. And so when we do our final calculation, how many micrograms are there in 22 milligrams? Our answer is, let me write it up here a little bit, it's 22,000. And we can also get that right here if we want to. So see, we wrote 22 milligrams here. How many micrograms would that be? It would be 22,000 micrograms as a check. And so that's that math, and just going through that multiplication like that. Okay, next thing is we want to talk briefly in this video about molarity. And molarity is a unit of concentration, and it was created by chemists who were functioning like chefs. So the first thing is molarity is something that you should think of like a chef is working with. And a chef who's working in a kitchen needs to make these kind of unit conversions. They need to also scale recipes up and down. And molarity was created by chemists functioning in a lab like chefs. So they made kind of a shorthand, and the shorthand is they said, let's make a unit of concentration. And so concentration is numbers, in our case of molecules, per volume. And biologists are really interested in concentration because, for example, concentration is how often bacteria eat. So here's some bacteria in a glass, and it's not how much total sugar is in the glass, but how concentrated the sugar is. If we double the concentration of the sugar, the bacteria get to eat twice as often. Or that could be a hormone in your blood and a hormone receptor, double the concentration of the hormone, and the receptor is filled twice as often, and the response is doubled, kind of like that. And so concentration is a big deal, so molecules per volume, and the chef chemist said, let's make a shorthand. Let's call these molecules moles, and we'll work in moles per liter. And a mole is a number, and it's very much equivalent to the idea that some people, maybe some chefs, decided to call 12 a dozen at some point. It's just a kind of an odd thing to think about. Like, you know, the number 11 doesn't have this extra name, but the number 12 has this extra name, doesn't. And moles is a big number, and that's because these molecules are usually at a surprisingly high number of them in a cup of water. And so moles, a mole, is equal to, in this same way, 6.02 times 10 to the 23rd. And people almost never talk about this number because they just use this word mole. So if you have 2 moles, you have 12.04 times 10 to the 23rd number. And so concentration, number of molecules per volume, is worked out at moles per liter. And molarity equals, big M equals moles per liter. Okay? Then that's the definition of it. And we went that far into it just so we could get started on what it's about. But now let's back up and say, do one of these simple conversions. How many molar is 17 nanomolar, like that. And this is a conversion we don't need to understand what we just talked about, because this conversion is just about the prefix nano. And so if we start out and we say, okay, we've got 17 nanomolar, I'm going to make a ratio to get to how many molar that is. This is the same thing as we've been working with. Nano is just the prefix we're dealing with, and so we're going to put nanomolar at the bottom, molar on the top. We take the big unit molar, the small unit nano. There are a billion nano molar in 1 molar. And we go through the math, and we get a small number that's like 10 to the minus, or 1.7 times 10 to the minus 8th molar. So it turns out to be a really small number. The key thing is that this unit conversion is what I call this simple conversion that we've been dealing with. It doesn't matter whether it's meters, grams, liters, molar, or if we had moles per liter. So if we wanted to, we could say how many moles per liter are there in 17 nanomoles per liter. That would be fine. And it could be either one of those, and these all are solved the same by this simple conversion. And that's the first kind of type of molarity problem. Is, oh, it's just a simple conversion. We don't need to understand molarity to do the simple conversion. The second one is that we just need to know that molar is equal to moles per liter. So we just need to memorize that relationship. And sometimes we switch them and there's no math involved. So I'll give you an example of that. And and it would be a problem where you'd say how many molar is 23 moles per liter, like that. That's a conversion question. We don't have to do any math. We can just rewrite it. 23 moles per liter, that's molar, and there would be 23 molar in 23 moles per liter. And so sometimes we just need to make that switch, like that. Sometimes the problems are combined. Number 1 and number 2 can be combined. So sometimes we could be asked how many millimolar are there in 23 moles per liter. So the first thing we need to do is just remember this, so we can convert that 23 moles per liter to 23 molar, and then do a simple conversion like part 1 to convert from molar to millimolar. So those are the first two types of questions about molarity, and it's a simple conversion and then just this relationship. And sometimes they need to be combined, sometimes they need to be combined in part of a larger problem. But those are two simple types. And then the third type is where it's a different kind of question. It's a recipe question, and this is where the chemist chefs are involved. So we're working in a kitchen, a lab, and we're asked to do a problem like how would you prepare? So it's a recipe question, just like how would you prepare a Caesar salad? How would you prepare a say a 2 molar solution of glucose? And so that's his third type of question, and it's a recipe question, and this is where these people decided they wanted to work with molarity, like that. And so the answer is, well, you'd need to get 2 moles and then dissolve that up into a volume of 1 liter. And so then the question is, how many moles are there? And you can't count them because the number is, the size of the molecule is really small. And so there's a simple relationship here for this part 3, and that is that 1 mole of any molecule is equal to its molecular weight, which is often abbreviated molecular weight, MW, in grams. And for our intro bio course, we don't need to calculate that, but it's possible we calculate the molecular weight, and the molecular weight is based on the size of the molecule. And so, for example, when you're counting out, say, oranges and watermelon, you can count out 12 oranges and 12 watermelon easy enough. But if they were so small they were invisible, we'd probably have to weigh them. And then you'd say, to get a dozen, comparable to a mole, to get a dozen of these, you'd have to weigh out less of this than oranges. So in that sense, the orange's sort of unit weight is smaller than the watermelon's unit weight. And that's what's going on here, is that for big molecules, we need to weigh out more grams to get the same number as small molecules, like that. So that's what this is all about, is it's weighing out things that are different mass and are invisible. And so if it said, how would you prepare a 2 molar solution of glucose? First you'd say, well, I would dissolve 2 moles in 1 liter. And then somebody would say, well, how would you actually do that? And you would say, well, I need to know the molecular weight of the glucose. And so if that's given in the problem, molecular weight of glucose equals 180, then you would say, okay, so if the molecular weight is 180, then 1 mole is 180 grams. So 2 moles would be 2 times 180 grams, or 360 grams. So how would you prepare a 2 molar solution of glucose, molecular weight of 180? I would weigh out 360 grams, because that's 2 moles, and I would dissolve it up to 1 liter. And that's a 2 molar solution of glucose. Then the next thing to say about this problem is, because molarity is equal to moles per liter, like that, whenever, for any problem, I make a 1 molar solution, or 1 mole per liter on paper, and then scale up or down. So let's look at this problem. Let's say it said, how would you prepare 100 milliliters of a 3 molar solution of glucose? Okay, so that's what it's asking us to do. It's a certain volume, a certain concentration. And what I say is, I'm going to make a 1 liter, 1 molar solution. Because to make a 1 molar solution of 1 liter, I would just weigh out the molecular weight in grams, which is 180. So 180 grams for glucose, and I would dissolve it up to 1 liter. So on paper, I say I'm going to make a 1 molar solution. I'll weigh out 180 grams and dissolve it up to 1 liter. And so the first step is to make this on paper, and it just depends on the size of the molecule, how much we'd weigh out. And we're given the molecular weight like that. So, you know, for some other substance, like say table salt, NaCl, the molecular weight is 58. So how would I make a 1 molar solution, 1 liter of sodium chloride? I weigh out 58 grams and dissolve it up into 1 liter. I always do that on paper, and then I scale up or down. So see this? It's I saying for this answer, for this question, I would say, okay, to start out, I make a 1 molar, 1 liter solution. I dissolve 180 grams up into 1 liter. And then I say, oh, oops, you want 3 molar. So I'm just going to take 3 times 180, and that's about 540. And so now I say, I would weigh out 540 grams and dissolve it up to 1 liter, and that would equal 3 molar. And then I say, okay, you don't want me to make a whole liter. This is 100 milliliters. And then I can do a simple conversion from liter to milliliter to get that final answer. And just to say it quickly and be done with this video, 100 milliliters is 1/10 of a liter. And so the final answer to this would be, how would you prepare this? I would take 54 grams of glucose and dissolve it up into a final volume of 100 milliliters. Final volume, total volume. And so that's how I solve any recipe question for molarity. This is a key. Is just to say, oh, I'm going to make a 1 molar solution, 1 liter, and then I'll scale up or down. I'll scale the concentration up or down, and then I'll scale the volume up or down to make that final thing that I really want to make in the kitchen or in the lab. And that's it for now. Thanks.